Here's the second half of relationships in a circle of 8.5. Okay, so we have this circle here, and we have erased some of it. So we have some white that we want to find the area of the shaded or the unshaded part, right? So in order to do this, just like you guys have been practicing, you want to find the area of the entire circle first, and then you want to find the area of the triangle inside. Now, to find the area of the triangle, we know we have a few methods. We can use area equals 1/2 base times height. We can use area equals the square root of s times s minus a times s minus b times s minus c, which is Huron's formula. Or if we know that the triangle is equilateral, we can use that area is equal to root 3/4 times s squared. So we have a couple options. Circles, we know that the area is equal to pi r squared, and once you find that those areas there, all you have to do is subtract them. So when you have the area of the entire thing and the area of the triangle, it's almost like you're cutting out that triangle, and how much are you left with? Well, that's what's left in white. So always remember that you want to subtract if you're taking something out of the shape. If you're adding it, you'd want to add them. So for example, if you have a square with a triangle or something that looks maybe like this, you would want to find the area of the square and then the area of the triangle and then add them together. All right, now here's something really important to recognize. Being able to recognize the difference between the area of a sector and the length of a sector. The area of a sector is the measure divided by 360 times pi r squared. We notice right here that we see that this is part of our area formula of a circle. So we're just finding a fraction of the area for the area. On the other hand, the length of the sector is that same fraction out front, but we're multiplying it by c. Or we can think of it like measure of 360 times pi times d, or 2 pi r, or however you want to think about it. But the important thing to recognize is that circumference is figuring out just the edge versus figuring out the area of the whole pizza slice. Now, you might have seen a couple times seeing the word sector versus the word segment of a circle. If I have a circle, this piece in here, this is called the sector. It's the whole thing. So a sector is made up of 2 radii. So this has to have 2 radii. A segment would be something like this, where you have a triangle, and this is what you're looking at. So this is a sector, and this is the segment. All right, because you're just trying to find this piece out here between the triangle and the edge of the circle.